connection between philosophy and the mathematical sciences has always been very close. Plato had written over the door of his academy the words, "Let no one enter here who is ignorant of geometry." It was Aristotle who codified the basic sciences into the categories and gave them the names that we use to this day. Some of the greatest philosophers have been themselves great mathematicians who invented new branches of mathematics. Descartes is an obvious example, and so is Leibniz and Pascal. In fact, most of the great philosophers, not all, but most, came to philosophy from mathematics or the sciences, and this tendency has continued into our present century. Bertrand Russell was trained first as a mathematician. Wittgenstein was trained first as an engineer. The reason for this persisting connection is, I think, obvious, and that is that the basic urge which has driven most of the greatest philosophers has been the urge to deepen our understanding of the world and of its structure, and this is also what creative scientists are doing. For most of the past, too, people thought that mathematics was the most indubitable knowledge, as well as being utterly precise and clear, that human beings possessed. So there have always been plenty of philosophers examining mathematics to try and find out what was so special about it, and whether this was something that could be applied to the acquisition of other sorts of knowledge. Ditto with the sciences, which were also thought to yield a very specially safe and certain kind of knowledge. What was it about science that made its results so reliable, people asked themselves, and could its methods, whatever these were, be used in other fields? These investigations into the concepts and methods and procedures and models that are involved in mathematics and in science have come to be known as the philosophy of mathematics and the philosophy of science. And it's with these that we're going to be concerned in this program, chiefly with the philosophy of science, though in fact we have someone taking part who is expert in both, Professor Hilary Putnam of Harvard University. Professor Putnam, I'd like to start our discussion from a standpoint which I think a very large number of our viewers occupy anyway. And it's really this. Since the 17th century, I suppose, there's been a spectacular decline in religious belief, especially in the West and especially among educated people. And for millions, the role that used to be taken in life by a worldview based on religion has been increasingly supplanted by a worldview based on science, or at least purporting to be derived from science anyway. And this is still enormously powerful in the hold that it has on people's minds throughout the West. Probably it affects all of us. So I think I'd like to start this discussion by getting you to pin down that scientific world outlook which is so influential in the modern world and which will be underlying a lot of what we're going to have to talk about.
Let me dodge the question a little bit by talking not about what scientists think now, but what many scientists thought 100 years ago or 75 years ago. Think of doing a crossword puzzle. You might have to change a few things as you go along, but towards the end, everything fits and things get added on one step at a time. That's the way the progress of science looked for 300 years. In 1900, a famous mathematician, David Hilbert, gave a list of 50 mathematical problems to a World Congress of Mathematicians, which are still very famous. It's very interesting that he included one problem which we would not call a mathematical problem very early in the list, I think it's problem 3, which was to put the foundations of physics on a satisfactory basis.
Just a small task. And that was for mathematicians.
That was for
not
mathematicians,
physicists.
not for physicists.
Yes,
right.
Yes.
The idea is
just to tidy it up.
That's right.
Yes.
The idea is Newton, Maxwell, Dalton, and so on had all put in all the parts of the story, and now it was just for mathematicians to basically clean up the logic, as it were. I think in a conversation we had a couple of days ago, you described this as a treasure chest view, and I like that picture. Because here's this big chest that we're just filling up. It's an accumulation, and you don't have to subtract, you don't have to take out. Occasionally you make a little mistake, but basically the idea is, or to shift the metaphor, like building a pyramid. You put down the ground floor, then the next floor, then the next floor, and it just goes up. That's part of it, this view of knowledge as growing by accumulation. The other part of it is the idea that the special success of the sciences, and obviously what we're impressed by is success. This culture values success, and science is a successful institution. But there's the idea that science owes its success to using a special method. And that comes partly from the history of science, from the fact that Newton, for example, lived after Bacon and was influenced by Bacon, and the idea that empirical science has grown up together with something called inductive logic. And this idea that there's a method, the inductive method, and that the sciences can be characterized by the fact that they use this method and use it explicitly and consciously, as it were. Not unconsciously, as maybe someone who's learning cooking might be using it, but pretty deliberately and explicitly. So I think that these two things, the idea of knowledge is growing by accumulation and growing by the use of a special method, the inductive method, are the key elements of the old view.
Yes, and if I were going to put the same thing, I suppose slightly differently, I think I'd say this, that for 200 or 300 years, educated Western man thought of the universe and everything in it as consisting of matter in motion. And that was all there was, whether from the outermost galaxies of the stars into ourselves and our bodies and the cells of which we're made up and so on. And that science was finding out more and more about this matter and its structure and its motion by a method which you just characterized as scientific method. And the idea was that if we went on long enough, we'd simply, as you said with your crossword puzzle metaphor, we'd find out everything there was to find out. We could eventually, by scientific methods, completely explain and understand the world. Now, that has been abandoned by scientists, hasn't it? Though, in fact, this hasn't got through yet to the non-scientists. There are still large numbers of non-scientists who go on thinking that that's how scientists think. But, of course, they no longer do they? I mean, this has started to break down.
I think it started to break down. I think it started to break down with Einstein.
Yes.
If I can drag in a bit of history of philosophy, screaming by the hair, Kant did something in philosophy, which I think has begun to happen now in science. He challenged a certain view of truth. Before Kant, no philosopher really doubted that truth was simply correspondence to reality. I mean, there are different words. Some philosophers spoke of agreement. But the idea is a mirror theory of knowledge. Today, I think, Kant said, it isn't so simple. There's a contribution of the thinking mind. Sure, it isn't made up by the mind. Kant was no idealist. It isn't all a fiction. It isn't something we make up. But it isn't just a copy either. What we call truth depends both on what there is, on the way things are, and on the contribution of the thinker, the mind. I think that today scientists have come to a somewhat similar view, that is, since the beginning of the 20th century, the idea that there's a human contribution, a mental contribution to what we call truth. The theories aren't simply dictated to us by the facts, as it were.
I'd like to ask you to unpack that a little, because I think that some of our viewers will find this idea a little puzzling. How can it be, some people will ask themselves, that what is and is not true can depend not only on what the facts are, but on the human mind? How can that be?
Well, let me use an analogy with vision. We tend to think that what we see just depends on what's out there. But the more one studies vision, either as a scientist or as a painter, one discovers that what's called vision involves an enormous amount of interpretation. The color we see as red is not the same color in terms of wavelengths at different times of the day. So that even in what we think of as our simplest transaction with the world, just looking at it, we are interpreting,
In other words, we bring a whole number of things to the world that we're not directly conscious of, usually, unless we turn inwards and start examining them.
That's right. I think the world must have looked different in the Middle Ages to someone who looked up and thought of the stars as up and us at the bottom, for example. Today, when we look out into space, I think we have a different experience than somebody with the medieval worldview.